The basic logic gates. For figure 1.1, this is the single inverter circuit with a 74LS04 hex inverter IC. When the input terminal A is 0, output is 1. And when input terminal A is 1, output is 0 because it's an inverter. Part 2, examining the basic operations of OR gate. This is the circuit of a 2-input OR gate with a 74LS32 and IC. So when inputs A and B are both 0, output is 0. When inputs A and B has input B as 1, output is 1. When input A is 1 and input B is 0, output is 1. When input A and B are both 1, output is 1. An OR gate works when either one of the input terminals has a logic 1, then output will also have a logic 1. If both of them are 0, then output is also logic 0. Part 3. Examining the basic operation of 7408 ON gate. This is the circuit of a 2-input ON gate with a 74LS08 IC. When both input terminals has logic 0, the output terminal is logic 0. When input terminal A is 0 and 1 for B, output terminal is 0. When input A is 1 and input B is 0, output terminal is still logic 0. But when both terminals A and B are logic logic 1, output terminal is 1. So for part 3, with a 2-input ON gate, we can say that an ON gate only yields logic 1 when both of the input terminals has logic 1 inputs. Part 4, multiple input ON gate. This is the circuit of a triple input ON gate with a 74LS11D IC. For a triple input ON gate, when all of the input terminals has logic 0, output is 0. When only input C has logic 1, output is 0. When only input B has logic 1, output is 0. When both B and C has logic 1, output is 0. When only input A has logic 1, output is 0. When only A and C has logic 1, A and C, output is 0. When A and B has output 1, output is logic 0. But when all of them has logic 1 as input, output is logic 1. Based from the results of triple input OR gate, it is only possible to have logic 1 output when all A, B, and C inputs are logic 1s. Part 5. Combinational logic circuit. This is a circuit for a AND/OR combination with a 7408 and a 7432 IC. For AND/OR combination, when all of the input terminals are logic 0, output is logic 0. When only input C is logic 1, output is still logic 0. When input terminal for B is logic 1, output is still logic 0. But when both B and C has input terminals of logic 1, output terminal is logic 1. When input terminal A has logic 1, output terminal is logic 1. When input terminal A and C has logic 1, output terminal is 1. When A and B has logic 1, output is 1. When all of the terminals is logic 1, output is logic 1. For AND/OR combination, since B and C is AND and A is OR, when AND gate has 1-1 logic, then the output will be logic 1. When OR gate has 1 logic 1, then logic 1 would be the answer. This is the circuit for AND or NOT combination with 7408, 7432, 7408, 7404, 7404, 7408, and 7432 ICs. For AND or NOT combinational circuit, when all of logic inputs are 0, output is 0. When only D is logic 1, output is still 0. When only C is logic 1, output is still 0. When C and D are logic 1, output is still 0. When B is logic 1, output is still 0. When B and D are logic 1, output is still 0. When B and C is logic 1, output is still 0. When BCD is logic 1, output is 1. As you can see. When only input A is logic 1, output is 0. When A and D is logic 1, output is still 0. When A and C is logic 1. Output is still 0. When A, C, and D are logic 1s, so let's put A, C, D. As you can see, output is logic 1. When A and B are logic 1, output is 0. When A, B, and D are logic 1, output is 0. When A, B, C are logic 1, output is still 0. When all A, B, C, D are logic 1s, output is 1. So for AND or NOT combinational circuit, here are the only three combinations that produced a logic 1 output. BCD logic 1 produced output logic 1. Logic 1A, C, and D has logic 1 output, and also all A, B, C, D have logic 1, logic 1 output. And that's all for experiment 1, the basic logic gate.